When looking at a side-side-side triangle that is not a right triangle, you're also going to use the law of cosines. Remember, the side-side-side is not talking about congruent or similarity proofs from geometry. It's talking about the given information, and you can see that I'm given three sides. So you immediately, when you see that, you're going to think of the law of sines. Okay, so side, side, side. And it's really important because side, side, side is something that you can easily obtain in the real world. You can easily go out and measure three sides of a triangle. And so you want to make sure that you realize this example is always the law of cosines. But we have a small problem. And the small problem that we have is that the law of sines traditionally is written what you need squared is equal to what you have squared plus the other side you have squared minus twice those two's product and then times cosine, law of cosines, of the angle that corresponds to what you want. Well, here's the problem. I don't have any angles. So in this problem, you're going to have to do the entire problem using the cosine angle formula, right? So the law of cosines for angles is cosine of the angle A. And remember how this works. You just subtract these two on the other side. So that'll give you A squared minus on this side, minus on this side, minus B squared, minus C squared. And then if these are gone, you would divide by this coefficient. And so it'd be A squared minus B squared minus C squared, and then divided by the coefficient on the front of this. Then, of course, I reversed it using the commutative property, so it wouldn't be equals that. Now, in other textbooks, you may see this written as B squared plus C squared minus A squared over positive 2BC. When they do that, they factored out this negative. I find that to be actually kind of confusing because it doesn't look like the original problem. So in this one, what we're going to do is we're going to look at this triangle, and we're going to realize that this side across from E is little e, and this side across from D right here, that's little d, or lowercase d. And of course, this one way over here from F, this is lowercase f. And we're going to write these out in terms of F and E and D, not in terms of A, B, and C. So to do that, I went ahead and just kind of pre-did that for you so that you could see it. What I did is I started with D. I just like to start in alphabetical order. That's why I did D. So D would be D squared minus E squared minus F squared, and then divided by negative 2. It's always negative 2 times these two things you're subtracting down here. That's why I like writing it that way, because you kind of keep all the negatives together. It's a really helpful way to do it. And to do this one, the next one I did in order was I did E, right? So I just go in alphabetical order. So cosine of E would be E squared, the side that it has, that matches it, minus the other two divided by twice those products. Remember, all the negatives stay together. So why didn't we do F? Completely unnecessary. You can always use angle sum. If I find two angles, I can find the other angle by simply taking 180 and subtracting these two answers. But before we type this in the calculator, we really have to remember something that's super important, which is I can't actually, I could type this in the calculator, but it's really not a good idea based on, the idea that it's going to, it's not going to be easy to type it. I'm not going to get the answer in one swipe. The highest degree of mistakes is created from how students type this into the calculator, believe it or not. So what I want to do is I want to solve both of these using inverse cosine. So I inverse cosine this, it cancels. Technically, remember, it's the inverse, so it's really just making 1 times d, which becomes d. That's a lot of information, but just it cancels. Over here, it doesn't. It creates a parentheses of all that. Same thing with this. This will cancel. And then down here, I have the result that I actually want to type in the calculator. And you may be saying, well, why didn't you go and type in all those things? Why did you leave it as D? Why didn't you say it was 5? Why didn't you say E was 6 and 2 was F? You could, and if you want to do it that way, here's a great place to do it. I want to show you something really neat on the calculator that I think will really open your eyes to how calculators and Desmos can just really make your life easier, especially when you move on past Algebra 2 and you're taking science and there's variables everywhere. So what you're going to see here is what I did was I actually I went back up here and I stored that, D is 5, E is 6, and F is 2 by using the store feature, which on the TI is STO, and on a Casio it's a little arrow. It looks just like this. So I did this. I said 5 store D, enter, 6 store E, enter, 2 store F, enter, and then I literally typed it in. Now, sometimes I will do it as separate things. You could have typed it all together, which I'll do in Desmos. You could type inverse cosine and then put this in a parentheses and get the answer. Just make sure your calculator's in degree mode. And you get that the first one that we typed in, which is right here, you can't label it as D, but that's why knowing that this D matches this D, we know that that's angle D. One thing about calculators that's really important is that they can't use lowercase letters. Desmos can, which you'll see. And so when they appear in the calculator, they appear as uppercase, even though we understand that as a human, that means angle, but we're really using it just to save ourselves some time and frustration. So these are actually all lowercase in reality. So it does give you an answer, it gives you a ratio. That's what I want you to see. That's why I did it that way. Remember when we learned about right angles, cosine should be ratios. And so it kind of all just loops back together. If you look at this formula, which starts from this law of cosines, when you get down to the bottom, you're just going back to a normal cosine ratio, and it gives you 51.318 degrees. So then I typed this one in. I didn't need to store these because I already stored them. So I typed that in, it gave me a ratio, and then I inverse cosine. Of course, I could have just done this all in one step, but I didn't want you to lose that ratio. All right, so that's how you would do it on a Casio or a TI. This particularly is a TI, but the Casio looks exactly the same, other than the button for storing is different, and locating the inverse cosine is in a different place. So what do I do on Desmos? Well, on Desmos, I type it in, and I want you to notice something. This is really interesting. Why did I have to type this as uppercase? Because if I type in lowercase e, it gives me a, oh no, I don't know what that is. And if you read it, it says, I have defined E as, E from the previous chapter, 2.718. It's it's Euler's number, or the natural growth constant. So I can't use lowercase e. It's one of the reasons I picked these letters, because I didn't want you to do that and then be like, why is Desmos not working? Desmos has defined E as its definition in the universe. It would kind of be like if I tried to say pi equals 6, right? It would freak out. It would be like, nope, can't do that. Pi doesn't equal 6. Pi equals 3.14. So instead of saying lowercase e for this particular one, we have to do uppercase E. I just wanted to show you that, so I picked those letters. And then I just typed it in. I typed in cosine to the -1, which is under function, right? Make sure it's in degree mode. You could, of course, type arc cosine. I'll show you that works, right? Arc cosine gives me the exact same answer as typing in here inverse cosine. It's the same thing. And then I did the same thing for this one right here. I just typed in inverse cosine of all of that information. It gave me the answer. And then I have the exact same answers you can see here that I have on Desmos. Just make sure everything's in degree mode. That's the number one. The number one thing students do wrong is they make a typo. The number two thing that students do wrong is they do the entire problem in radians and they think they're doing it wrong, and they're not. So on Desmos, another thing that students might do wrong is make this capital and put it lowercase here. Just make sure everything matches. That's why I love being able to see it all on one screen. So now our job is going to be to take all this information that we have and organize it. So remember, to organize the information, you're solving the triangle. That's the purpose. Solving means find all angles and sides. So notice that for the sides, I just wrote down what they gave me, right? E is 6, D is 5, F is 2. I just wrote that out over here. You would want to include your units. So keep in mind that a teacher would look at that and say, oh, -1, -1, -1. You're going to want to make sure you include your units. It becomes more and more important as you enter trigonometry and above. And then this number, remember, I got from right here, right? That number is 51.317. You can always remember what angle you're doing, because it's the first thing right here. Remember, that matches. D is angle D and E is angle E. So there are those answers. So how do I get F? Well, I take 180 degrees and I subtract 51.3178. I just literally copied it and put it there. I take 100 and then I subtract 110 and I get that measurement right there. So I can fill that in real nicely and I have the whole thing solved. Remember, this should always add to 180. The sides don't have any of those nice relationships. You can also just obviously do that on a calculator. You can do that on a phone calculator. It just is, you just go to 3 or 4 decimal places. 3 decimal places is important for later AP classes. That's why we're doing it now. I don't want you to do a 10th and then later be told to do 3 decimal places. When you take an AP test or an SAT, they're looking for 3 correct decimal places. So that's why I always calculate with maybe 5 or 6 so that my end answer has more than that.